Today I'm going to explain how to use the program SLICE. SLICE was developed to quickly and accurately calculate lesion volume and location. We use it to calculate stroke volume, but you could also easily use it for any brain lesion that produces a distinct border. For more information on how this program was developed and its use, please see the publication on the screen from the Journal of Neuroscience Methods, just published in February of 2013 by Park et al. SLICE was coded in MATLAB, so you must already have a copy of MATLAB to use it. Once you have downloaded the program, you can run the program cal lesion, and then you're ready to begin. To use SLICE, your brain sections should be coronally sliced, with the sections being equidistant from each other. Our sections are Nissl stained, and that works well with SLICE, but really any stain that provides a distinct border between the lesion and the rest of the tissue will also work. Another thing to keep in mind is that the inner slice distance should be the same for each brain. So begin by collecting and organizing your images to analyze. To calculate lesion volume per animal, put all of your coronal images for that animal into a folder. So I've already done that for rat 1. You can see there are a bunch of images in that folder. So SLICE works by opening a folder and then going through each subsequent image. So you're going to want to organize them from most anterior to most posterior. So image 1 here is the most anterior section that we have, and then this is the most posterior. So now I can run cal lesion, and this panel will pop up. Next step is to open the folder with our animal of interest in it. And you can see that the folder has been loaded with all of the images inside it loaded over here. So you're going to want to click through and find the first section with the lesion on it. So here I know that it's section 6 and that the lesion is on the right side. So you can click that it's a right-sided lesion, and this will be maintained through all of the rest of the images for this animal. The next step is to click on the setting button, and then you can change the parameters of your stroke volume estimation. So in our case, our image resolution is 2400 pixels per inch. Our brain slices are 40 microns, and the distance between each slice is 960 microns, so I'm just going to leave that. The next step is to click the Show B and W button. This step will color pixels of your image black or white in order to form a distinction between the brain and background, and thus start to give you a border for the brain. You can change this threshold to increase or decrease sensitivity to pixel intensity. In other words, if you feel as though the preset threshold is underestimating your brain size, you can increase the threshold. And if too much background is being colored, decrease the threshold. So you can do that right here. So if I thought my brain was being undershaded and too small, I could increase the threshold, which there is obviously too much, or you could decrease it. And that's clearly not shaded enough, so our preset is a good choice for this set of images. The next step is to click on Find Border. And a border will be defined by SLICE. This actually looks like a good border, so I'm not going to change anything. But if you find that you're having a border drawn around any of this stuff on the outside of the slide, which can happen fairly often because these slices can get kind of messy, you can change the noise size, and that will help to fix that. So SLICE defines anything as noise as anything that any number of connected pixels under this value. So right now the brain is way over 5,000 pixels that are connected, so it's not noise and it's all within the border. If any of this stuff is pretty big, it could fall within a border, and then you would want to lower this noise. The next step is to click Draw Center Line. Just pretty self-explanatory. You will just click and then drag a line down through the brain. So what happened here is that SLICE took the border of the non-lesion side and then flipped it over onto the lesion side. This is particularly useful for hemispheres with huge lesions, because right now it's a pretty small one. You can see if it was a big lesion that it would be hard to estimate this border. But I'm going to go ahead next and fit our non-lesioned side to our lesion side. it's a pretty good match. And then this X is the reference point that slides and animals are normalized to. So you're going to want to put that so that the bottom of the X is aligned to the top of the brain for each slide. Okay, that looks good. So the next step is to trace. You can zoom in to better see your stroked area, and then also drag to move the image. So you trace just by clicking, and then these dots will be connected. Alternatively, you could click and drag to get a curvy line if you prefer to do that. I prefer to click, so I'm going to go back to doing that. You can see this is a small lesion, so you don't really need the estimated border so much, but it is really helpful for large lesions. So now that's traced. Right click, and the area will be highlighted, and you can see now we have a stroked area that's been calculated. And this image is finished. So we can move on to the next image in our stack. And you will just go on like this until you don't see any more stroked area before you calculate the volume. Another thing you want to do at some point is to set this AP reference. So if you click on it, you can see that you have all of your images here. So what you can do is match one of these images, and you only have to do it to one. You can match it to a coronal slice from a standard rat atlas. So let's say this one corresponds to an AP position of 1.7 millimeters for that slice. So this allows you to reference your stroke volume to the rat atlas and know precisely where the volume is located. So I'm just going to do this image very quickly. Okay, so let's say that these were our only two sections that had a stroked area in them. At this point, you would then click on Calculate Volume. So what you have here is a 3D model, a calculation of volume, and then you can also make a 2D plot with an overlay of each image. So the volume calculation over here was done either by the cylinder method or our own slice method of interpolation. So to find more information about these methods, you can see our publication. The error between these methods is small, and really either gives you a good estimation, so either is suitable to use and to publish. So here you can see the 3D model of the stroke volume. This is two images, so clearly it's a little rough, but that is nice to have to compare the shape of the stroke across different animals. So what you can do in this panel is to highlight and then move over your images that have stroked area, and then you can do a two-dimensional plot. So this would be a coronal section. This is just an overlay of them. So you can see we have a slight misalign at the top, because if we're saying this is our reference point and this is the top of the brain, then these should really be somewhat more aligned. So you can move these sections to get a better model, so you can see how you could do something like that, and then click between them. So I'm just playing around with that. I'm not sure that it helped. And then you can save and then replot the slightly different three-dimensional volume. So also at any time during this process, you can save and come back to your work, because you could have many sections with stroke volume in them, or stroke area rather. You can click the Open Project button to open previously saved work. So if you have any more questions, please see the SLICE manual, our publication or email us at slicehelp@gmail.com. Thank you for watching.